In this video, we're going to talk about the basic idea of the mean and the standard deviation. So this is in the beginnings of chapter 3 in our book. Okay, as far as the mean is concerned, the mean is just the same thing as the average. One of the first things you learn when you're talking about statistics before you actually talk about a statistics course is to take the average of test scores, right? Okay, so in our language and statistics, we call it the mean, and we use the symbol x bar. And so that is all that the mean is. It's just taking the average of values. And average, of course, means that if we had, let's say, 5 test scores, right? If you had 5 exams, and these were your scores, and you wanted to average them, so to average them, we would just add them together. And then divide by the number of them that we have. Now, when you look in the book and in my notes, you might see the following notation. So this symbol is called a summation symbol. And what it's saying is it's saying add up. So, of course, we add up. So this symbol means add. And this is saying add all our test scores. So this X to the side, and sometimes it'll have a subscript, means that we're going to add up all of our scores. The N is the number of them that we have. So here I had 5 test scores, so I'm going to divide it by 5. If I had 6, I divide it by 6. Okay, so the average I think most people are comfortable with. Now the question is, what is standard deviation? What standard deviation is doing is it's a number, and the symbol that is used is the letter S. And what it is doing is it is seeing how much the typical value changes from the average. Sounds weird. Okay, so let me go ahead and show you an example of what I mean, the idea of it. So if I told you that the average test score was a 77, and then I told you that S is 2.3. What this is saying is that S, being the standard deviation, is saying that the typical exam score is, or the typical data point, varies by 2.3 from the mean. So what I'm saying is that if you were to score, like, let's say, score an exam score of a 90, according to this, that's really weird. The majority are going to be varying, or the average variance, if you will, is a score of 2.3 points from the number 77. Versus, if I had something that was like S equals 12, it's saying that the typical exam score is varying by 12 points. So this is going to have, obviously, a wider spread of data. Okay, now what does that mean as far as our graphs are concerned? Well, a histogram that has a small standard deviation, it doesn't have to do with the number of bars per se, but how tight the bars are. Okay, so this would be an example of a graph that has a small standard deviation because it's all sort of clustered. Versus, so I'll start my picture kind of similarly so you can see that, you know, they can be similar graphs, but then what happens is you basically have more bars and more spread. Okay, so a smaller standard deviation is going to be a tighter graph. A larger standard deviation is going to be a wider graph. It doesn't have to necessarily be symmetric, by the way. I know I drew a symmetric graph, but I'm just saying that you're going to have a lot of spread in the data. There can even be gaps. So for those of you wondering, hey, can there be gaps? Yep. This is still going to have a larger spread versus a tighter spread. So this is going to have a smaller standard deviation. And this is going to have a larger standard deviation. Okay. In the next video, we'll show how to use StatCrunch to calculate both of these things.